All right, let's talk about the absolute cutting edge of AI. Today, we're diving deep inside NeurIPS 2025, which is the top AI conference in the world. And what we're finding is a major shift happening right under our noses. We're going to unpack the key trends and breakthroughs that are literally defining what comes next.
So I want to start with just one number, 21,575. What is that? Well, that is the staggering number of research papers that were submitted to NeurIPS this year. That's more than double what it was just a few years back. This, right here, this explosion, it's the backdrop for everything else we're about to talk about.
But here's the thing. Underneath all that noise, a really different story is starting to take shape, and it's the big idea for us today. The consensus coming out of NeurIPS is crystal clear. The old playbook of just making models bigger and bigger and bigger, well, that era is giving way to something new, something more mature. The whole field is now wrestling with the much harder problems of efficiency, control, and of course, safety.
So here's how we're going to break it all down. First, we'll look at that research explosion. Then we'll get into the new problems everyone is tackling now that we're past the scale is everything phase. We'll look at the jump from just processing data to taking action, how generative AI is being forced to meet reality, and how the science itself is growing up. And finally, we'll tie it all together to see what the next era of AI really looks like.
All right, first up, the AI research explosion. And really, this is all about a field that's kind of being crushed by the weight of its own incredible success. It's forcing everyone to rethink the very basics of how they do science. In this chart, wow, this really puts the human side of that growth into perspective. You see over 21,000 papers submitted. To handle that, you literally need an army of people, over 20,000 reviewers, and more than 1,600 area chairs. It's created this intense peer review gauntlet that every single new idea has to survive. The scale itself has become one of the biggest challenges. Which brings us right to our main event. Now that we have these incredibly powerful foundation models, the goalposts have moved. The research isn't just about building the biggest engine possible anymore. Now, it's about figuring out how to steer that engine, how to make it more fuel efficient, and, how to make sure it actually has brakes. And there's this fantastic metaphor floating around that captures this perfectly, the alignment tax. Think of it this way. Training that giant base model, that's just the down payment. The real ongoing cost is this massive tax you have to pay in data, in compute, in endless hours of verification, just to make that powerful thing safe, reliable, and actually useful for people. A huge chunk of the research we're seeing now is all about one thing. How do we lower that tax? So how do you lower it? Well, one of the biggest ideas is to get way better at learning from messy, real data. Old school methods like DPO needed perfect, super clean data from humans. But the new hotness is techniques like Compo, which can pull out useful signals even when the data is noisy or ambiguous. That makes the whole alignment process so much more efficient and practical for the real world. Okay, but here's the other side of that coin. Control is one thing, but security? That's a whole other battlefield. The cat and mouse game between AI builders and the people trying to break their systems is getting seriously sophisticated. We are way past just trying to trick a chatbot with clever words. The attacks are now targeting the very core of the model's mind. And this technique, Largo, is a perfect, almost scary example. It's a new kind of jailbreak that's like something out of the movie Inception. You're basically attacking the AI in its dreams. You don't start with a bad prompt. No, you first find a weakness deep inside the model's own representation of the world. And then, and this is the genius part, you use the model against itself to create a perfectly innocent-looking prompt that secretly triggers that deep vulnerability. Of course, it sails right past the safety filters, because the real attack is buried layers deep. So, all of this, defending against these wild attacks, building these powerful models, paying that alignment tax, it all costs a fortune. And that brings us to the next big theme, efficiency. The critical question that researchers are obsessed with right now is this. What if you could get the power and performance of a much bigger model without actually having to build and pay for one? And we're seeing some really clever answers. One is called the parallel scaling law. The idea is you run a bunch of copies of the same smaller model in parallel, and together they act like one giant model, but using way less memory. Then there's another system called Weaver, which is just a really smart idea. It uses a big model to generate an answer, but then it has a whole team of smaller, cheaper models check its work. You're shifting your expensive compute from just creating stuff to verifying it, which is a super efficient way to boost accuracy.
Okay, so all this focus on efficiency and control, it's all pushing us toward the next big frontier. We're moving away from AI that just sits there and looks at data and toward building agents that can see, reason, and, this is the key, act in the real world. This is the rise of embodied intelligence.
And right now, it looks like there are two main paths forward. On one side, you have systems like CAR1. This is all about end-to-end learning. You basically build an agent that's designed to go out, have experiences, and just figure things out for itself, evolving on its own. But then on the other side, you have a totally different philosophy with approaches like ground compose reinforce. Here, you first teach the agent a bunch of basic skills, and then you teach it a kind of language to string those skills together to solve brand new problems. It's a fascinating mix of new school deep learning and old school symbolic AI.
All right, let's switch gears and talk about something we've all probably played with, generative AI. Because the game isn't just about making cool-looking pictures anymore. The new challenge is making stuff that's physically plausible, logically sound, and just plain correct. It's about making generation finally meet reality.
And what's driving this is a problem people are calling the verification gap. It's a really simple idea, but it's a huge problem. Basically, our models can generate images and words at a mind-blowing speed, but our ability to automatically check if that output actually makes any sense, if it follows the laws of physics, is lagging way, way behind.
So this gap is forcing everyone to totally rethink their approach. The old way was, generate, then filter. Just make a ton of stuff and hope one of the outputs is good. The new holy grail? The goal everyone is chasing? It's to generate correctly by design. To build models that just understand the world so well that they don't make dumb physical or logical mistakes to begin with.
And you can see this happening with some amazing new techniques. Take something called CAD. It lets us get inside the model's head and edit how it thinks about concepts. It's like having Photoshop for the model's brain, letting you precisely erase a tree or amplify a car. And then you have stuff like GeoDiff, which actually bakes a 3D understanding of the world right into the generation process. So the final image is guaranteed to be geometrically correct from the start. So we've talked about all this incredible futuristic tech, but none of it just happens in a vacuum. And that brings us to the final major theme from NeurIPS, and it's a big one. It's about all the behind-the-scenes work of building a better, smarter scientific community for AI. It's about the infrastructure for reliable, reproducible progress. And you can literally see the field growing up right here on this timeline. Just a few years ago, starting a track for datasets and benchmarks was a new idea. Now, in 2025, it's treated as a first-class citizen, with the same rigorous review as the main conference. On top of that, they've launched a brand new track for position papers, which is basically a formal place for researchers to debate the big picture direction of the field. This is a huge deal.
So what's the big takeaway here? It's that the AI community is sending a very clear signal. They're saying that progress isn't just about the next shiny algorithm anymore. Creating a high-quality dataset, building a tough new benchmark, or writing a thoughtful critique of where we're all headed, that is now officially considered a top-tier scientific contribution. This is what a maturing field looks like.
Okay, so let's step back and pull all of these threads together. This massive shift away from just thinking about scale and this new focus on efficiency, control, and scientific maturity, what does it all actually mean for the next era of AI?
When you really look at everything coming out of NeurIPS this year, it boils down to these four massive themes. 1. A huge pivot to efficiency and control, instead of just raw scale. 2. The real, tangible rise of embodied AI that can actually do things in the world. 3. A deep, serious quest to make our generative models trustworthy and grounded in reality. And 4. The maturation of the entire scientific community that makes all of this possible.
And this leaves us with one final, pretty provocative question that's just hanging in the air. For years, if you asked, what's next in AI, the answer was easy, a bigger model. But all these trends from NeurIPS 2025, they suggest a totally new possibility is on the table. So the big question for 2026 is this. Is the next world-changing breakthrough going to come from just building an even more massive model? Or is it going to come from a fundamentally smarter, more efficient embodied AI that's actually capable of making its own scientific discoveries? That's the tension that's going to define the next chapter of AI.